About proof by contradiction. In homework 1, several students have asked questions about this and still not very confident about this type of problem. Let's go over this again. Okay, and so to assume it is false first. Assume this is false, and then we going through the logic procedure, which means using the logic identities, which is observed, and so that you end up with a contradiction statement. So in one statement, b equal to 1, and then b equals 0. Therefore, you succeed in finding the contradiction, which means it cannot be that left side is 0 and one side is 1. So therefore, you proved. Because if you have that happen, and there will be contradiction. Therefore, which means it cannot happen. So that proved. So, but then here is another losing end. But why not assuming this side is 1 and left side is 0? Okay, and looks like it's a convenience. No, actually, you must do that to be a valid. You must also do the other way. So this side is 0, that side is 1. You can prove. Maybe it's harder, but in the homework, I didn't take any deductions because we are beginners. But let me go over the other way. So you must do the other way to be a valid proof. So then let's assume this side is 1, the other side is 0. Okay, that's not true, right? Which means we have to prove that cannot happen. But in this particular case, it becomes easy. Okay, we proved left 1 equals 0 case. So then left side is 1, that is right side is 1, left side is 0. So but this one, we simply use this distribution rule. The left hand side become exactly to right hand side. Obviously, if you're assuming it's 0 or 1, obviously it's a contradiction. So there's no more need to do. But in this case, we're lucky. Both ways are simple, but we assume both ways we reach the contradiction. So which means 0 equals 1, 1 equals 0 cannot happen. So that's the logic. So once again, you assume it's false by assuming 1 equals 0 and 0 equals 1, and then you reach a contradiction. You say, well, that since it's contradiction, it cannot happen. Therefore, we proved the original statement. Now, one more step, actually one important, do we really need to do both ways? And turns out we do. So we must reach contradiction in both, assuming this false statement and also assuming the other way statement 1. Both cases, can we have a valid proof by contradiction? Okay, let me go over this step. It's very simple logic. So suppose you have a true identity already proved. Alright, already proved. So then you can of course do both ways, right? Suppose we have a general left side equal one side. Suppose this is true. Okay, and then we can do proof by contradiction. We are arriving at all the contradiction and so on. So then by adding, then we add additional variable d on the left hand side. So d over here, and put a or, and then this immediately become another general statement, but it becomes a false statement. Okay, and in this false statement, imagine we try to do our proof by contradiction, assuming only one side on this one. Okay, right hand side equal to 1. Okay, and left side equal to 0. So this side is equal to 1, that side is 0. Obviously, if that side is 0, both d and that must be 0. Therefore, by this argument, since this part is already true, we reach our contradiction. But if we only do this side, and we will say, well, this statement is true. See? Because if you do this side, if we say this is 1, that is 0, and this statement is true. But in fact, this statement is not true. But then if you do that side is 1, left side is 1, and right side is 0, and no, we do not have a contradiction because the statement is actually false. Yeah, so if you do this side is 1, so 1, 0 equals 0, it's false. There is no contradiction because that side is 0 because this one. So this exceptional case, okay, and invalidate the general statement that you can do proof by contradiction by supposing one side equals 0, the other side equals 1, and not do in the reverse. That's not going to work. Okay, you have to do both ways. So in short, you need to do both ways. Okay, and you assume one left side is 1 and one side is 0. That's false case. And you have to do it the other false case, and left side is 0 and right side is 1. You have to do both ways. So that concludes this video. So to prove, you assume the statement is false, but there are two false cases. We need reach contradiction in both cases. So to have a valid proof by contradiction of a statement. That's the end. Thank you for listening.